All right, welcome to our second NTI day of 2026. What I'd like for you to do is to go ahead and take out your note packet and open up to lesson 7.4. We started this lesson on Friday. We're going to be picking up where we left off. So if you need to pause the video and go grab that, you can do that. And before we continue, just one reminder. The notes you take today, you will actually take a picture of and turn in for a grade. So make sure you're not just watching the video, but that you are watching and carefully taking down notes. Those notes will get turned in on Canvas via picture, and if you don't, you won't receive that credit. So make sure that you're watching and listening carefully and taking really good notes. All right, let's continue. The other thing that you're going to need, you need your scientific calculator today. If you forgot to bring that home, you can go to a website that has a free scientific calculator. I'll write it on the screen. It is www.desmos.com, and there is a free scientific calculator there. If not, just use your TI-84. All right, so let's pick up where we left off. Now, on Friday, we learned about the trig ratios called sine, cosine, and tangent. And I'll remind you, we learned these three what sound like nonsense words, so, ka, and toa. And those were shorthand for the trig ratios that we learned. So the S stands for sine. So sine of an angle is equal to the opposite side over the hypotenuse. The O and H stand for opposite and hypotenuse. C of ka stands for cosine of an angle equals the adjacent side over the hypotenuse. And then finally the T of toa is tangent of an angle equals the opposite side over the adjacent side. Now, one of the things you might have noticed in Friday's lesson and on the homework that you should have worked on over the weekend was that every time you tried these, x ended up in the numerator of your fraction. And in actually both classes, someone asked, what happens if x is in the denominator? We're going to deal with that today. So let's take a look at example 8. In example 8, let's circle the acute angle labeled 33 degrees, and let's label the corresponding sides. So x is our hypotenuse. 15 is our opposite side. The blank side down here is the adjacent side, which isn't even labeled, so we're not going to end up using it. Then we ask ourselves, okay, which trig ratio uses the hypotenuse and the opposite side? Well, that would be sine, right? Opposite over hypotenuse. So let's go ahead and set this up. We can say sine of our angle, which is 33 degrees, equals the opposite side, 15, over the hypotenuse, which is x, opposite over hypotenuse. So we have an issue here. X is in the denominator. We need to get it out of the denominator. Now there's a short way and a long way. I'm going to show you first kind of the long way, and then I'll show you a shortcut if you want to use it. Now x is in the denominator. 15 is being divided by x. So to undo that division, we would need to multiply both sides by x. That breaks it free of the denominator. And now our equation reads x times sine of 33 equals 15. Now we would like to get x by itself. So what we should do is we should get rid of sine of 33. It's being multiplied by x, so now we can divide both sides by sine of 33. Over here that cancels. And so that means x is equal to 15 over sine of 33. Well, this is where we need our calculators. Let's now type that into our calculators. Now, before we type anything, though, it's always worth checking to make sure that we're in degree mode. So if you have a newer TI-84 calculator, you can see the word degrees up here. Or if you press the mode button, you should be able to see that degree is selected. If it's not, if radian is selected, go ahead and choose degree. Okay, let's go ahead and type it in. 15 divided by sine of 33 degrees. So we'll close our parentheses there, and there's our answer. We'll round to the nearest tenth, so it's going to be approximately 27.5. So down here, we can say that x is approximately equal to 27.5. Now I mentioned that this was kind of the long way to get your answer. There is a shorter way. Allow me to show you that off to the side, and if you want to use this moving forward, you're welcome to. Back at the beginning, we wrote this down as sine of 33 equals 15 over x. And we had to perform two operations to get x by itself. We had to multiply both sides by x and then divide by sine of 33. We can actually do that in one step moving forward, but it depends on our understanding of division. So down here, I'm going to write a very simple division question, right? Imagine if I wrote 5 equals 15 divided by 3. I think everyone agrees that that is, in fact, true. Now, watch what I'm about to do. I am about to switch the location of two pieces of this division question. I'm going to switch the location of 5 and 3 and write a new equation. Imagine if I wrote 3 equals 15 over 5. I switched the location of these two numbers and it was still true. 15 divided by 3 equals 5, therefore 15 divided by 5 equals 3. If that's true, then I can do the same thing up here to get x by itself. If 15 divided by x equals sine of 33, then 15 divided by sine of 33 should equal x. So I can switch the location of these two pieces and say x equals 15 over sine of 33. Again, just like how I was able to do that here. 15 divided by 3 equals 5, 15 divided by 5 equals 3. These two pieces can be interchangeable and the equation is still true. That applies up here as well. So moving forward, I am going to use this kind of shortcut method. If you don't like that, you're welcome to multiply by x and then divide by sine or whatever you're dealing with, sine, cosine, tangent. All right, let's take a look at number 9. In number 9, let's go ahead, circle the 43 degrees, and label the sides. X is the hypotenuse, and 36 is our adjacent side. This is our opposite side, but since it's not labeled, we're not even going to use it. All right, now let's think, which trig ratio are we going to use? Well, we look at what was provided. We have the hypotenuse here, and we have the adjacent side here. That means we've got to be using cosine. Well, let's do that. We can now say cosine of 43 degrees equals the adjacent side, 36, over the hypotenuse, which is x. Let's use the rule we just learned, right? If 36 divided by x equals cosine of 43, then 36 divided by cosine of 43 will equal x. We can switch the location of x and cosine of 43, and our equation still remains true. Now we can go ahead and type that into our calculator. And when we do, 36 divided by cosine of 43, we get our answer to be approximately 49.2. X is approximately equal to 49.2. There's our answer. All right, now let's move on to example 10. Same approach. Let's circle our acute angle here, 72 degrees. We can mark that 25 is our opposite leg and x is our adjacent. And we ask ourselves, of the rules of our trig ratios, which one uses the adjacent leg and the opposite leg? Well, that would be tangent. Remember, tangent is opposite over adjacent. So let's go ahead and set that up. We can say tangent of our angle, 72, equals the opposite leg, 25, over the adjacent leg, which is x. We have that same scenario where x is in the denominator. So a reminder, we can just switch the location of tangent of 72 and x, and the equation holds true. We can say x equals 25 over tangent of 72. I'll give you a second to type that into your calculator. And you should find that x is approximately equal to 8.1. All right, why don't you pause the video and try number 11, and then I'll reveal the answer in just a second. Try number 11 on your own. All right, so here's the answer to number 11. You might have noticed in this particular example that x did not end up in the denominator, right? We had adjacent and hypotenuse, which means we used cosine. Cosine of 64 was equal to adjacent over hypotenuse, or x over 11. Then to get x by itself, we just multiplied both sides by 11. So x was equal to 11 times cosine of 64, and when you type that into your calculator, you should find that x is approximately equal to 4.8. Now we're going to transition to the last two examples on this page, which are word problems. You'll notice one of the first things that is missing from these is a diagram, so that's going to be one of the first things that we create. Let's see what number 12 says. It says Jake leaned a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? Okay, so first thing, let's just draw ourselves a right triangle. We know in these questions we're dealing with right triangles, and we need to think about, in the context of the question, what each side of the right triangle represents. Well, the first thing, I think the bottom side we can safely assume it represents the ground, okay? Now, it talks about how he leaned a 12-foot ladder against his house. Now, as you think about a house stands up perpendicular to the ground. So the edge of the house is standing straight up like this, and the slanted side represents the ladder leaning over. Mine's leaned over quite a bit, but it gives you an idea of what we're dealing with. Now let's go ahead and label the dimensions. It tells us the length of the ladder is, in fact, 12 feet. So we can say that this is 12 feet right here. They tell us that the angle formed by the ladder and the ground, that would be this corner over here, right, where the ladder meets the ground. They tell us that that's 68 degrees. So let's label it as such. So this is 68 degrees right here. And what they want us to find is how far from the base of the house did he place the ladder. Now the base of the house would be the bottom of the house right here, and where he placed the ladder on the ground is right here. So we're trying to find this distance along the ground. So we're going to mark that as x. Now let's go ahead and label these sides, right? Here's our acute angle, 68 degrees. We know that 12 feet is our hypotenuse here. And we know that our side labeled x is our adjacent side. Okay, so these are the pieces that we're going to be using. We have adjacent and hypotenuse. If you remember from SOHCAHTOA, adjacent and hypotenuse is cosine. We're going to say that cosine of 68 degrees will be equal to the adjacent side, x, over the hypotenuse, 12. This is another scenario where x is in the numerator, so we don't have to rearrange things. All we need to do is just multiply both sides by 12. That cancels out, and this is what we can type into our calculator. 12 times cosine of 68. Go ahead and do that yourself and see what you get. All right, when we round to the nearest tenth, we should get roughly 4.5. But remember, in the context of a real-world problem, we have units. 4.5 what? 4.5 feet. So the distance from the base of the house to the base of the ladder is 4.5 feet. Okay, last example on this page. It says a ramp is used to load suitcases on an airplane. If the cargo door is 7 feet from the ground and the angle formed by the end of the ramp and the ground is 25 degrees, how long is the ramp? Okay, so once again, let's draw ourselves a diagram. Let's begin with a right triangle, something like this. There we go. And of course, this should represent the ground. This represents the ramp. And, this ramp is loading suitcases onto an airplane. And so, the vertical side here is really just represent that vertical distance up to the hatch on the airplane. So, you can imagine suitcases, right, kind of being loaded into there. All right, now let's label. It says the cargo door, which is this right here, here's the door, is 7.5 feet from the ground, 7 feet from the ground. So we should go ahead and label it as such, 7 feet from the ground. 7 feet is this distance right here. And then it says the angle formed by the end of the ramp and the ground, that would be right here, is 25 degrees. So let's label that, 25 degrees. They want to know how long is the ramp? Well, the ramp is the slanted side, so we should put x right here. Now let's go ahead and classify the sides in their relation to the 25-degree angle. Well, I think we would say that x is the hypotenuse. We know it's the hypotenuse right here. And we know that 7 is the opposite side over here. We think about SOHCAHTOA. Which one of our trig ratios uses opposite and hypotenuse? Well, it would be sine. So let's set up our equation. We'll begin by saying sine of 25 degrees. I'll put that right here. Sine of 25 degrees is equal to the opposite side, 7, over the hypotenuse, x. In this case, we do have x in the denominator, so remember our trick. If 7 divided by x gives you sine of 25, Then 7 divided by sine of 25 gives you x. We can switch the location of these two pieces. So I'm going to go ahead and do that. Let's rewrite this as now x equals 7 divided by sine of 25. 7 divided by sine of 25. And that is what you want to type into your calculator. Go ahead and do that now. Type in 7 divided by sine of 25. You should find that the answer when rounded to the nearest tenth is 16.6 feet. That is the length of the ramp in this scenario. Now that finishes out the lesson, but there's one more example that I want to show you so that tomorrow you're prepared to attempt some of the homework. So what I'd like you to do is, for a moment, go ahead and put your note packet aside, and I want you to pull out your homework packet. So take out your homework packet, and I'm actually going to work through one of the problems with you. I want to look at number 12 in the homework packet. Again, we are looking at homework 4, and we're looking at number 12. You'll notice none of the examples we did in the lesson today had two triangles. Here we do have two triangles, so we need to figure out how to attempt this. They want us to find DC, the distance from D to C, which is right here. The problem is, in that triangle on the right, we don't know any of the side lengths. So we're going to have to hold off on this triangle for a minute and begin with this triangle over here. Now, as we look at this triangle on the left, which I'm going to highlight in a different color, we need to ask ourselves, what do we know and what should we try to find? Well, these two triangles, the one I'm highlighting in blue and the one that's marked in yellow, share this middle side right here. Okay? And in fact, I'm going to call this middle side, why don't I call this middle side A? Okay? I would like to find the length of that middle side because knowing that will help us look at the triangle on the right. So let's set up an equation. 54 degrees is our acute angle. A is our opposite side. 20 is our hypotenuse. Remember, so, ka, toa. Opposite over hypotenuse is sine. So we can say sine of 54 degrees equals A, that side we're trying to find, over 20. And if I want to solve for A, all I need to do is to multiply both sides by 20, like this. Okay? And we would find that A equals 20 times sine of 54. Now, before you type that into your calculator, as I've cautioned you before, you never want to round answers before you get to the final answer. So for now, I want to leave it in this form, 20 times sine of 54. So in my diagram, I'm going to go ahead and label it that way. Okay, so right here, I know that this middle side right here is 20 times sine of 54. I know it's a little odd, but we want to make sure that we keep our answer exact until the very end. Now we can take a look at the yellow triangle over here. And since we're trying to find this little piece right here, we can just call this, I'll just call this B since I used A already. Circle the 28 degrees and let's label the sides. B is our adjacent leg, and the 20 times sine of 54 is our opposite leg. Now remember, so, ka, toa. Which one of our trig ratios uses opposite and adjacent? It would be tangent. So let's go ahead and set this up. We know that tangent of 28 degrees will be equal to the opposite side, which, as we said earlier, is this expression, 20 times sine of 54 over the adjacent side, which is B. Now you'll notice the variable that we want to solve for is in the denominator. Remember our trick from before. We know that if 20 times sine of 54 divided by B equals tangent of 28, then 20 times sine of 54 over tangent of 28 equals B. We can switch the location of these two pieces right here, and the equation still holds true. So let's do that. B is now equal to 20 times sine of 54 over tangent of 28. Now watch carefully as I type this into our calculator. We want to make sure we don't make any mistakes. I want to type this in exactly like a fraction, exactly the same way we wrote it on our paper. So there's two ways to do this. If you have a newer calculator like mine, if you press the alpha button and then you press the button right next to alpha where it says x and t and theta and n, it creates a fraction and you can type into that fraction. If you tried that and nothing happened, there's another way to create a fraction on your calculator. Press alpha, y equals, and that very first option, n over d, just press enter, and you get a fraction. Okay, so one more time. One way to get a fraction is press alpha and then the x button right next to it. Or if that doesn't work, press alpha and press y equals. Then choose that first option. Either way, you should be able to set up a fraction. And let's type it in exactly the same way we wrote it on our page. In the numerator, we wrote 20 times sine of 54, and I'm going to close that parentheses. And then in the denominator, right, we had tangent of 28. Tangent of 28. Okay, and we press enter, and there's our final answer. Now we are cleared to round this to the nearest tenth. If you rounded early and used that rounded answer, you would have gotten 30.5 instead of 30.4, which is not as accurate as we'd like to be. So let's go ahead and write down that answer. Here we go. We'll say that B, or actually, this whole side was called DC, so why don't we just call it DC, is approximately equal to 30.4. All right, that wraps up our lesson for today. Now I want to make it really clear what you need to document and turn in on Canvas today to receive credit. So what do you need to turn in today? Well, first thing, the examples we just worked through on the 7.4 notes. Examples 8 through 13, you need to take a picture of those and turn those in on Canvas. But we also did one example from the homework, number 12 from the 7.4 homework. So please make sure to take pictures of those pages and turn those into Canvas before 8 p.m. tonight. That's when they're due. If anything is turned in after 8 p.m., you won't earn full credit. If you have any technical issues, let me know. Otherwise, have a great day.